guys, I'm here again. We want to find the mean and variance of binomial distribution. In our last class, we treated the mean and variance of a gamma distribution. Binomial distribution is one of the discrete distributions that we have in mathematics or statistics. Binomial distribution has a probability mass function of P of x equal to xi, which is equal to n combination x, p raised to the power of x, q raised to the power of n minus x, where your x is from 0, 1 to n. So this is the distribution, the probability distribution of a binomial. We are interested in calculating the mean, which is the expected value, and is given as NP. The variance is also NPQ. So how do we get NP? How do we get NPQ? Let's look at how we can get our mean and variance. If you recall, the expected value, which is the mean of a discrete probability distribution, is given as summation x, probability of x equal to xi. Your I is from 0 to what? 0 to n. Our P of x is what is here. So we are replacing everything here, which is this. We are replacing this by this in order to further our calculation. So let's go there. Expected value of x is equal to summation x, or let's change this to xi. So we know that our xi is running from 0 to n. So we have x times n combination x, p of x, q raised to the power of n minus x. So your xi is from 0 to n. To move further here, this is a combination. We need to express this. This is the same thing as summation x times x n factorial all over n minus x factorial times p raised to the power of x, q raised to the power of n minus x. So your xi is from 0 to n. We want to look for a way to eliminate this x, and to do that, we need to express the value of x factorial. As you know that x factorial, we know that x factorial, or generally n factorial, is equal to n into n minus 1 into n minus 2, like that. So we need to express this. So we're going to have expected value of x to be summation x I equal to 0 to n. So of x times, we're going to express this once, n n minus 1 factorial. Let's stop there because we, according to the formula of mean, we need n. So to get n, we need to express this. So here we are going to leave this x, n minus x. We have to express this, like I said, in order to eliminate this. So we are going to have x into x minus 1 factorial. We are going to stop there because this will take care of this. Then, what source for the goose is source for the ganders. We need to express this as well. Since we remove one here, we also need p from the destination. So we need to bring 1p out. So in doing that, you agree with me that this is the same thing as p raised to power of x minus 1 times p raised to power of 1. Because if we apply law of indices, this will also cancel this. And we're going to have our px back again. So this qs will remain there, which is n minus x. So let's move further. This will take care of this. So we are taking this out. We are also taking this value out. So we have np summation xi from 0 to n, left with n minus 1 factorial all over n minus x factorial x minus 1 factorial q raised to the power of x minus 1, then q raised to the power of n minus x. So we are almost there. We are looking for np. So what are we going to do to all this? This is a distribution on its own, and the sum of any probability distribution must be equal to 1. To make it easier, we can also reduce this so that it will sound like a distribution. We can easily say let's take everything here, x minus 1 to be equal to a, so that we can have this easily. Expected value of x equal to np summation xi from 0 to n, then n in minus 1 factorial all over n. Our x is now, let's find the value of x here. So if we are to find x here, since this is equal to a, we can easily say our x will be equal to, when 1 comes here, will be equal to a plus 1. So let's substitute it here. If we now put it here, that is minus x, which is minus a minus 1, minus a minus 1 factorial. Then we replace this by a. Everything here is a, so a factorial. Then p raised to the power of a. Instead of writing this, we write a. Then q raised to the power of what is here, the same thing as what is here. So we are having the value here as n minus a minus 1. So our work is almost done. Note, in the sum of any distribution, if you have a probability of x, si, so if your xi is equal to 0 to n, so the sum of any probability distribution must be equal to 1. Therefore, we can easily say that expected value of our x is equal to np times, because everything here is a distribution on its own, which is times 1. The answer is now np, which is our mean. That's how to find the mean of binomial distribution. Let's look at the variance. How do we find the variance? How do we find the variance? obtain the variance. So the properties, or one of the properties of variance is the variance of any variable or variable of x is given as a expected value of x squared minus expected value of x all squared. Meanwhile, this can also be expressed as summation x squared p of x equal to xi, xi is from 0 to n, then minus summation x xp into x minus xi, then xi from 0 to n all squared. We've calculated this already, which is the same thing as our mean, the distribution we just calculated, and it's our NP. So this one is our NP. So meaning this distribution now will be reduced to summation xi from 0 to n x squared probability, then minus NP all squared. Let's call this equation asterisk. So we are going to work on this second moment. So after this, we take the answer to this equation. We will now simplify to get our variance. So let's solve this. So this, let's use the facts. Let's use the facts as a hint. Let's use hint. I want to use the facts that x squared is the same thing as x plus x minus 1 x into x minus 1. So let's use the fact of this, so that if we expand this, we can easily get x plus x times x squared, and x times this minus s. This, we cancel this, which is equivalent to x squared. So this expression is the same thing as this. We are just trying to make our work faster, so we can reduce this to this. So we are going to use this as a hint now. We can now have our expected value of this, which is x squared, as summation xi from 0 to n. So instead of writing x squared now, we are replacing it by this value. So we are going to have x plus x minus 1, x into x minus 1, then p of x equal to xi. So everything here now is now for x. So how do we expand this? If we expand this, we are going to get equal to, so this time this will give us a summation xi from 0 to n of x, then we are equally attaching or expanding with the probability equal to xi, then plus this times this, we're going to have a summation x into x minus 1, then times the probability, which is probability of xi, so xi from 1 to 0 to n. So this is also the mean, which is the expected value of x, and is given as np. So meaning we are left with this now. We are left with only this to calculate. We are left with this to calculate. So we can go back to equation 1 now to have from equation asterisk. From this equation asterisk, we can say our variance of x equal to, so this, which is this, and everything here is now this. So we can easily change it to np plus, we want to find this, so summation x into x minus 1, the probability, so xi equal to 0 to n, then minus np all scale. So let's call this equation asterisk 2. Now we are going to call it equation asterisk 2. So we need to find this. When we find this, we substitute the formula, we just simplify. That will be our final answer. So you can easily solve this. Expected value or summation x into x minus 1 with the probability of x, so xi equal to 0 to n will be equal to, let's attach the probability x into x minus 1, xi from 0 to n, then the probability, this is the probability, which is n x and combination s, q raised to the power of x, q raised to the power of n minus x. Just the same manner, we are going to bring out the parameters here. So this is the same thing as summation x I from 0 to n, x into x minus 1 times n factorial over n minus x factorial, then p x, q raised to the power of n minus x. So you want to cancel this. You want to, just like the way we did in the first one when we calculated for me. So we want to cancel this, and to cancel this, we are expressing the value of x in factorial expression twice, and whatever we do here, we are equally doing it to this, equally the value of p, which is the parameter. So this will now be summation si from 0 to n, then we're going to have n into n minus 1 times n into n minus 1 into n minus 2 factorial all over n minus x factorial. We're going to express x factorial x into x minus 1 into x minus 2 factorial. So we let it go to 2 because we need to cancel this completely so that we will be left with this. Then this also will be p square times p raised to the power of x minus 2. Because if you multiply this and this using the law of indices, we are still going to get this. So this will remain q n minus x. So this, take care of this. So we are taking this out, p square. We're also taking n into n minus 1 out. So we're going to have p square then times n into n minus 1 summation xi equal to 0 to n, so which is equal to n minus 2 factorial all over n minus x factorial x minus 2 factorial, then p is the power of x minus 2, then q is the power of n minus x. So everything here is also a distribution. Like I said, the sum of any distribution must be equal to 1. That is one of the answers of probability distributions. The sum of everything here must be equal to 1. So without wasting much of our time, if everything here is equal to 1, we can easily see our p square times n into n minus 1 equal to times 1. Therefore, our expected value of therefore summation x into x minus 1 p of x equal to xi must be equal to n minus 1 times np scale. So this answer now, this answer, we are going to replace it by this. We are going to substitute this to this so that we can get our variance. So let's do that. So variance now, variance of x will be equal to, the variance of x will be equal to, so here we just substitute everything here and is this. So have np first, np, then for this is what we got plus here, the answer of this n minus 1 np square, so that's all, minus the mean, which is this, minus np all square. So let's simplify now. This will be np, when you multiply this by this, will give you n square p square minus this time this np square minus open this n square p square. So this will take care of this. So we easily have np minus np square. So the common factor, what is common here? np is common into, left with 1 minus what? 1 minus p. But from parameters in a binomial, we were told that p plus q must be equal to 1. So meaning that your q is now 1 minus p. So if you replace everything here by p, this answer can be easily be npq. So that is the answer. Thank you very much. In our next class, we are going to look at another way we can derive the mean and variance of a binomial distribution if you don't want to follow this procedure. Please like, share and comment. Subscribe to my YouTube channel. Just follow me on Akanle Isaac Formulamaths. Thanks very much.